All right, section 2, here we go. What are the advantages and disadvantages of oil? So, petroleum, oil, same thing. Good old stuff, sucked out of the ground. It is an extremely complex set of chemicals that are mixed together into a stew. And so, it isn't one thing, but a multitude of things that are put together. And we separate those out and then utilize them for their purposes. So, it's a liquid, of course. It's full of hydrocarbons, and the products are used for all kinds of things under the sun. So, only about 35 to 50% of the oil that's in the ground are we actually capable of getting out of the ground. The vast majority of it stays underground. And so we need to improve that. But the stuff we get out of the ground gets used for all kinds of things. Gasoline, heating oil, asphalt, plastics, all kinds of things. So here shows you some of the things that come out of the ground as part of what makes up crude oil. And then actually the plastics industry itself are chemicals derived from that. And this is how that process works. This is called a fracking tower, this thing over here on the left. And this is how we separate out oil. So once oil is pumped out of the ground, it goes to the refinery. And the refinery basically uses heating to boiling points of the various components of oil to separate it out. So it's heated, and then the heated crude oil is pumped into these large towers. The lighter weight molecules move to the top of the tower because they have lower boiling points, and the heavier molecules have higher boiling points, and they settle to the bottom. And so what you get is this leveling effect, where you have thick, heavy stuff like asphalt, followed by grease and wax, naphtha, diesel, oil, heating oil, aviation fuel, gasoline, and then gases like propane, and butanes, and methanes, things like that, are separated out, and then they're sucked off at each level. And so these components then are separated out, and then actually we can take those and alter those to turn them into more of whatever we may need. When it comes to oil, there is a group called OPEC, which is quite influential in this whole process. There's 12 countries that make up OPEC, and they're listed down here. You see that there's a variety of them, quite a few of them in the Middle East, 6. There's a couple in Africa, 4, and then Venezuela and Ecuador also fit in that category. And this is a group of, OPEC stands for the Organization of Petroleum Exporting Countries, and they have 2/3 of the oil reserves basically proven, and then a bunch of potentially unproven ones, because, for instance, Saudi Arabia, which we know it has lots of oil, but it never really releases exactly how much it has. And so this unproven reserves is kind of a question mark because the knowledge isn't openly shared between countries for a variety of reasons, but mostly economics. And so these guys make set prices of oil around the globe. They are a very powerful entity. Oil prices, rising oil prices, what's with that? Now, oil prices are actually falling right now. The information in your book and stuff is, of course, several years old, and so it varies a little bit, but nonetheless, all of this information is still factual. Global oil production peaked in 2005, so we've sucked as much out of the ground as fast as we possibly could in about 2005. After this, we've had sharp oil price increases. It was, $4 a gallon at one stage in the past, and currently that's not the case, but nonetheless, it's because of the fact that oil is a non-renewable resource. It's a commodity that will be running out, and so as a result, even though oil prices are low right now, it is not something that can happen forever. It's eventually going to have to shift. And so alternative energy sources are currently being worked on in a variety of different arenas. Governmental programs, private industry, things like that are working on it. So why are oil prices rising? Well, they're not rising now. But why were they rising? Higher food prices are a result of higher oil prices. So if it costs more to ship stuff there, you're going to see food prices rise. So it doesn't just affect filling your gas tank. It affects all the other things that are involved in the situation. Airfares for planes are higher when the fuel prices are higher. it does affect energy waste. So when it's more expensive, people have a tendency not to drive just for the sake of driving or go places that because it's too expensive for them to go. There's usually an upgrade in public transportation when fuel costs are high. They usually work on making smaller, more efficient cars. They potentially, people start working on shifting away from carbon-based energy sources. And then most products with petroleum are more expensive, like plastics and all kinds of things like that go along with it. So fuel prices affect far more than just you filling up your own gas tank. Right now we're going to see the benefits of that because the oil prices are low currently, so all of these things are easier. All the pluses like the food and the airline is a better place, but it also stifles some of those switches to alternative energy sources. So how much do we make and how much do we use? So in the United States, this is what we use oil for. 70% of it's used for transportation, hauling stuff around our country. 23% is used in industry, 7% is used in individual households, and 1% is used for electricity. Not a very common electricity source. The only petroleum-based power plant is in Massachusetts currently. All the other ones are decommissioned or aren't used for that. So transportation is the bulk of it. If you look over here on the right, this shows you where oil comes from. So the U.S. produces a large quantity of oil. We consume all that we produce. We mainly produce it in the Gulf of Mexico and in the North Shore of Alaska. We consume that, but in addition to consuming that, we get oil from Canada, Mexico, South America, Africa, the Middle East, and Europe. And you see we get very little from Europe, relatively speaking. We get the most from Saudi Arabia, basically, but the Middle East. We get quite a bit from Africa, followed by South America being the next one. So we import from a variety of different people around the globe, as well as consuming our own. Which brings us to ANWR. So we constantly have to have our own oil reserves, kind of protect our own bottom line. So we can consume and use other people's oil and our own oil, but we don't want to use too much of our own. So for a variety of safety reasons, we need to have national security reasons. We should have our own oil available to us in large reserves and available. And so we need to constantly be looking for new oil sources. And one was found in ANWR. We talked about this on the last video, but ANWR is in northern Alaska. You can see right here on the map where it's located. It's not open to oil and gas development right now. And the reason why is it is a tundra biome, and it's actually it's a breeding ground for caribou. So they migrate up there and breed. And so it's a pretty fragile ecosystem, and it's a wilderness area, and so it's off limits to that, to drilling and stuff. But some people want it to be opened up. And so the argument is, should we open it to that or not? And that's where the crux of this issue comes. Do we drill in ANWR? Do we not? We talked about the quantity of oil present in there and what are the benefits and drawbacks of it. You'll see that our amount of oil we've been using has went up over the years. And then you can see what the output of oil would be for the Arctic refuge if we did that. And so it would offset our issues for a while. It's not a long-term solution, but it is a decent short-term solution. But it does have some environmental impacts, mainly messing up caribou breeding populations. So the debate is, should we do it or should we not do it? And that falls in lots of different situations. They've argued allowing it to happen only during, say, winter months, so they can build ice roads in, drill, and get out before the summer comes. That would avoid destroying too much of the tundra environment and not disrupting the animal populations in the area as bad. But nonetheless, it's a debate that still is a hot button issue. It comes up in most presidential elections. It comes up often. You'll hear about it in the news. So what are the benefits and drawbacks? Well, these pictures, I think, sum of that up well. What's good about regular oil? We got a good supply for the next about 50 to 100 years. Low cost, high energy output. It's easy to work with for transportation to get to and from places. And you don't use a lot of land to get oil. You just suck it out of the ground. It's not like coal. You have to alter the landscape to get it. The technology for getting out oil is pretty well developed and set up for us right now. and it's got a very efficient system developed for distributing it around the planet. So these are all advantages right now. Disadvantages, we need to find substitutes for it within the next 50 years or we'll be in trouble. It gets large government subsidies to ensure that the cost is low and all of that kind of stuff. It has a lot of environmental costs that are not translated on in any other facet to the consumers. Right now there's an artificial low price built into it for its usage with government subsidies and things, which can create some problems there. It is a polluter. It releases CO2 when it's burned, and it causes lots of pollution, including oil pollution or water pollution when we have oil spills. Here's a breakdown of some things really fast. 43 of the CO2 on the planet comes from transportation and the burning of oil for it. 60% of the U.S. import goes through refineries in hurricane areas, so along the coast and stuff, which has a possibility of creating some dramatic environmental issues. Now, what are we doing? Well, we've got all the easiest accessible oils out of the ground already, and so now we're looking at alternative ways to get oil out of the ground. And some of those are what they call heavy tar-like oils, are sometimes referred to as tar sands. And it's this a lot thicker, goopier, lower quality stuff than the original is. And so how are we going to handle that, and should we start using it? Canada has a lot of oil sands in it, as 75% of them, and they've actually already started mining and processing those and selling those. And then in the United States, we have 72% of the world's oil shale here in the United States, which is another opportunity. The Brachian Formation kind of fits in that, North Dakota a little bit. So, is this a viable option? Should we start using it? Well, a lot of people argue yes, and right now it's actually being worked on. What are some issues with it, though? It has very high sulfur content. So when we burn this stuff, it has a lot of impurities in it. Those impurities create a lot more pollution-based issues. The extracting and processing of it creates what they call toxic sludge, which is really pretty nasty goop. And then using it involves a lot of water. Currently, they're running that problem in North Dakota. The amount of water they're consuming in order to drill and take care of this oil issue is far more than they originally believed. And so that is a concern right now. They're using millions of gallons a day in taking care of the oil up in North Dakota. And then, of course, it requires a lot more energy to change this stuff and get it ready to go than the easier oils. And so your net energy usage is not nearly as good with it. So pros and cons of using this alternative type of oil stuff. Moderate cost for the oil sands is a good thing. There's a large potential supply of it in Canada and to a certain extent in the United States. It still can be easily transported between the countries. It still has the efficient distribution system, and there's a lot of good technologies already built around it. Bad cost. It's still a lot higher cost than conventional oil. The amount of energy yield is not as good out of it. There's still lots of environmental costs that aren't taken into account. It takes a ton of water to process it and use it. It really disrupts the land because it's more like coal mining than it is oil drilling, especially in the tar sands in Canada. You have severe water pollution as a result of it and air pollution from its emissions. And so it's a dirtier option, it's a less energy efficient option, it's a more expensive option, but it might be a necessary option with the state of our oil consumption.